Okay, there seemed to be some difficulty with activity 120D, numbers 7 through 12, identifying a real world situation as being a function or not. So I thought I would take a couple of minutes and run through that so you had something to go through and see where you may have gone wrong. In all cases, the question is this a relationship? Is this relationship a function? And what I noticed when I was going over your homework was and your classwork was that we did not necessarily use the definition of a function. So let's pull that back up here. So this was activity 120A, the first thing that we had. In order for a relation to be a function, each input must be mapped to exactly one output. So this piece right here, this idea of each input being paired to exactly one output, this box, this sentence, this stuff right here, is the question we ask ourselves in all of the numbers 7 through 12 on activity 120D. And that was what I kind of noticed, that people weren't using that sentence as their jumping off point. So let's look at this. So in number 7, the independent variable is the time you ride in the car at 55 miles an hour, and the dependent variable is the distance traveled. So those are our variables, so that's important. So independent variable, time you ride in a car, that would be our input. And the distance traveled would be our output. So at every stage, you have to ask yourself the question, is each input paired with exactly one output? Or in this case, you make the substitution and you say to yourself, is each time ridden paired with exactly one distance? Is each time ridden, I don't even know if that's good grammar, paired to exactly one distance? That's the question. And the answer in this particular case is going to be yes. Because the 55 miles an hour is held constant. If you drive for 1 hour at 55 miles an hour, there's only one possibility for the distance that you can go. If you drive for 2 hours at 55 miles an hour, there's only one possibility. But it does always go back to this statement, each input being paired with exactly one output. And then we switch that out there. So yes, because, let me get my pen back here. Yes, because each amount of time can only result in one distance traveled. And that is because we are keeping the 55 miles an hour fixed. All right, so that's number 7. We'll go through it with number 8 as well. The independent variable is the cost of the taxable item. So there's your cost. That is your input. And the dependent variable is the sales tax owed. That would be our output. So you ask yourself, is this relationship a function? So we ask the question, does each input get paired with or mapped to exactly one output? And then what we can do is we can actually erase the word input and replace it with what the input actually is here. Does each cost get paired with one output? Erase the word output and replace it with the output actually is one sales tax owed. And that's a question. And in this case, once again, we would say yes, because the sales tax in the state of Connecticut is 6%. So if you buy something for $1, the cost, It doesn't matter what the item is, whether it's $1 candy bar or $1 cup of coffee or $1 spool of thread. It doesn't matter. The sales tax owed is going to be the same. Because if we're not looking at the item, we're looking at the cost of the item. So here the answer is yes, because each cost, now we're not talking item, we're not talking that it's a spool of thread or that it's a coffee or that it's a candy bar. It's the cost that's important. Each cost can only result in one amount of sales tax. Okay? Now we're going to go through a few more of these. For 9, 10, 11, 12, we might go a little more quickly, but we will continue to go through them. Okay, now let's take a look at number 9. Let me scroll here a little bit for us. So once again, the independent variable is the gender of your teacher. So gender would be our input. The dependent variable is the subject they teach. So the subject would be our output. So once again, is this relationship a function? We have to ask ourselves that usual question. Does each input get paired to exactly one output? And what we really should do here is now replace the words input and output with what the input and the output actually are for, you know, the relation, the situation would be given. So I'm going to erase the word input, and I'm going to replace it with gender. And I'm going to erase the word output, and I'm going to replace it with the word subject. So now the question is, does each gender get paired to exactly one subject? And the answer to that is no. This is not a function. Because a gender can get paired to multiple subjects. All right, so that is a quick recap of how to do that. I did 7, 8, and 9. That would leave 10, 11, and 12. And so maybe what we should do here is I'm going to put 10 right there. Pause. Maybe you should pause the video at this point. Identify the input. Identify the output. You should ask yourself the question, does each input get paired with one output? Replace the words input and output for the specific words of the problem, and go from there. And maybe try answering 10 and 11 and 12 on your own. You can pause the video so you can read them, answer it on your own, come back after you finish them, unpause the video, and check the answers. Okay, maybe you've unpaused the video and you're back now, so let me go through the answers pretty quickly here. The independent variable is the length of the side. Dependent variable is the volume of the cube. So the question would be, does each side length get paired with one volume? Since the length here is the input and the volume is the output, we want each input paired with each output. And the answer for this would be yes. Since a cube, and that's kind of specific here, that it's a cube, has all the same side lengths. Any side length only gives one volume. Number 11, Independent variable is age, not the student's name, it's their age. And the dependent variable is number of siblings. And so we asked our question, so does each input get paired with one output? Does each heir get paired with a single number of siblings? And the answer is no. Different people or one age can pair to multiple numbers of siblings. And number 12, time is the independent variable. The population is the dependent variable. Is this relationship a function? Does each point in time, does each input get paired with just one population? And the answer for this would be yes. At any given time, at any single time in history, the world will only have one population. Okay? I made this video because I looked at your work and they weren't great, so hopefully as we talk through 7, 8, and 9, and then you tried 10, 11, 12 on your own, it went better in regards to getting ready for the upcoming assessment.